Hi everyone, my name is Akhil Jain. Welcome to PodTest. Today we are going to discuss about what is the asynchronous behavior. I'll show you practically what exactly is asynchronous behavior with the help of a demo application. Also, I will show you why it is a problem for our automation script and why therefore we require a solution to handle this problem. So let us understand the use case first. Over here we have the client and the server, and we are going to make some API calls. One of the API call is /name and another is the /description. Now at the server, the processing time for /name API will take almost around 2 seconds, and processing time for /description API will take around 1 second. And we are going to fire first /name API and then the /description API. Now in a synchronous world, what will happen is you will fire a /name API, right? It will reach to the server will process it, it will take around 2 seconds and then pass a response. The client will receive the response and then it will fire the next call, which is /description, and the server will receive it, server will process it and will send the response back, right? So in that case, the time instance would be T1, this would be T2, then this would be T3, and this would be a T4, all in sequence, right? Now let us see the asynchronous behavior for JavaScript. Now what happens is, because JavaScript waits for none, and due to the asynchronous behavior, if not properly handled, how this will work? So client at time T1 will send this request /name. It will reach to the server, and server, because it takes around 2 seconds to process it, it will not provide the response instantly, right? So now JavaScript will not wait for the response. It will rather move to the next command at time T2 and fire this /description API call. Now once triggered, it will again be received by the server and server will process it. Now out of both the responses, right, which the server has to provide, the description one takes only 1 second, right? So server will first provide the response for the description API. So at time T3 we will receive the response, and then after another second we will receive the response for /name API also, right? So the sequence of the execution is, at T1 we fired /name API, at time T2 we fired /description, at time T3 we received the response from /description, and then at time T4 the response from /name. Now you see, this is not the expected sequential flow. This could create some problems, right? What if the /description API requires an input which will only come from the output of this response, which is /name API response? But due to this asynchronous behavior of JavaScript, it will not wait for the response, right? It is not waiting for this response. It is just going ahead and firing the next command in sequence. Now due to this async nature of JavaScript, it creates a problem for our automation scripts to run, wherein our automation scripts require some sequential flow, right? You will be navigating to a page, you will be filling up the form and then submit, then wait for the page to load and then only move to the next step, right? That is how the flow would be. But if you don't handle it correctly, what will happen is JavaScript will just read through the commands, right, which you have written in your scripts, and just keep on firing, right, without waiting for the response to be fully loaded or completed from the server side. It will not wait for it. It will just move to the next commands and keep firing whatever it sees in sequence. And that is where we need to provide a solution. We need to handle this behavior in JavaScript using some mechanisms, so that our execution starts behaving in a sequential way, where it will wait for the first operation to complete and only then move to the second one. Now let us see the Backend Demo Application, which will provide us the response for those APIs. So this is based on Spring Boot. So what I've done here is I've created two methods here, getName and getDescription. So these are those methods which will get invoked once we receive the request for this endpoint /name. This method will get invoked, and once we initiate the endpoint for /description, this method will be invoked. Now over here, to simulate the wait time or the processing time which the API takes to return the response, what I have done is I have added a sleep time. So in getName I am providing a sleep time of 2 seconds. So what I'll do is, let's say the request is received by the backend application here, the function gets invoked, and over here it will wait for 2 seconds, do nothing, and after 2 seconds it is creating an object and then returning that object as a response of this API. So with slash name endpoint we will receive the response, that too after 2 seconds. And similarly, once JavaScript invokes the endpoint of this API, which is slash description, this method will be invoked, and over here it will wait for 1 second, do nothing, and after that it will create an object and put this output and return it as a response of this API. Now let's initiate those API calls from JavaScript. First of all, let us use Postman and validate whether the Spring backend application is working, and also verify the response time of each API. So over here I have two APIs, get name and get description, and let's trigger it one by one. So this is for get name. Let me trigger it. This is the endpoint and I'm triggering it. So, and you can see that we have received the response. You can also check the response time. It is greater than 2 seconds, and this is what we wanted. Now let us check the get description endpoint also. Let's invoke this. We have received the response, running platform for Aztec, and over here the response time is just above the 1 second, 1042 milliseconds, which is just above the 1 second part. So our backend application is working fine, and we have validated the response and the response time using Postman. Now let us move on to the JavaScript part, and let's try to invoke these API calls from there and see the async behavior in action. Now let us see our JavaScript code and see how we will be invoking both the APIs without handling the async operation. So this is an HTML file which I will render, and it has a script section which includes the JavaScript file which I will be using to invoke the APIs. And this is the JavaScript file where I have created two different functions, call get name and call description, where call get name will be using the fetch method and hitting the endpoint slash name and then print the output from it. And similarly, the call description uses fetch, which is again hitting the endpoint slash description and again providing the output. Now to invoke these functions, what I've done simply is I've just invoked these functions, right? Over here you can see I have not done any handling of async operation. I'm not using any mechanism to handle this. My current intention is that if you don't handle the async operation correctly by using the mechanism which JavaScript provides, how the output will look like. So let's just trigger this and see the response. So once we render that HTML page, this is how it will look, and this is that JS file. Let's do a code walkthrough of it. So here we are just defining the function, right? And over here we are making the invocations. So in the sequence of steps, right, we are first making an invocation for get name method, which is using fetch method and invoking this endpoint, right? And then once the response would be retrieved, it will be printing the logs on the console. And once it completes, it will then move to the next line of code, which is called description, and then invoke this. And over here again the fetch method is used to invoke the endpoint, and after that we are waiting for the response and then printing the response out of it. And then there is no line after the call description, so the JS script will stop the execution. So this is what you think, right? How things will flow, right? But this is exactly things will not work like due to the async behavior. Let's see the response of these invocations on the console tab. Considering the sequential flow, we consider that first this will be printed, name is, and then the value for it, and then description is, and then the value, right? Let's see in the console tab what exactly it prints. Let's just reload the page. It will trigger the JS file again and make those invocations. You see, that is the exact opposite of what we thought, right? First of all, the response from the description method is being printed, right? And then the name method. Why is so? This is exactly because of the async behavior of JavaScript. Now just the last part to explain why JavaScript behaved that way, right? So we all know that JavaScript has a call stack, right? This is the call stack, right? Over here when we said call get name, right? So this invoked the function, right? So what it does is it created, so by default we already had this global execution context, right? After that it created a new execution context for this method invocation, which is call get name, right? So let's term it as EC1, right? Execution context EC1, and this was the global execution context where the complete JS script is running, right? This JS file. Now once this invocation is made using the execution context 1 for call get name, it reached here, right, in the call get name method, and it invoked this fetch method which is hitting this endpoint. Now fetch method returns us a promise, right? We can check here, it returns us a promise. And then what we are doing is we are using a then clause to resolve the promise, and this is the callback function which needs to be invoked once the promise is resolved. Now you would be knowing that there is a concept of micro task queue in JavaScript, right? And this queue, the micro task queue, now this is the queue which will hold the callback functions which needs to be invoked once the promise is resolved, right? And similarly we have another queue which is the callback queue, which is for the normal callback functions. So this is the callback queue, right? And we have the event loop which keeps checking these two queues and also monitors the call stack, and if the call stack is empty, it will pick up the items from these two queues and start placing in the call stack so that they can be executed. So now let's just move to the execution part again. So what happened was what happened is we invoked this function call get name, right? It reached here, right? After this it fired this method fetch, and this was the promise, right? And these are the callback function which needs to be invoked once the promise is resolved, right? So these are kept aside, and this execution context will get removed from here, from the call stack. JavaScript will not wait for the response of these promise, right? It will just simply place these callback functions into this empty queue, right, which is the micro task queue. So this function will come here, right? The name function. Let me write here name, right? We can identify it from here. After this, JavaScript moves to the next line, which says call description, right? Now first of all, this execution context is already popped up, right? So there is nothing here. So we have already moved to, the control again moved to this global execution context, where we are moving to the next line, which is call description. Once this is invoked, right, a new execution context gets created here, which is EC2. Okay, now as part of this EC2, this invocation will happen, which is the fetch method will be fired. Again, this is the promise. Now again this will return a promise, and there is a callback function associated with it. So JavaScript will just simply place them into the micro task queue, and let me name it as callback description. So these callback functions will be placed here once the promise gets resolved, right? So this execution context also gets popped out from the call stack. Now we have only this default global execution context here. Now it checks like whether it has something to execute. As you can see, there is nothing to execute here, right? So this global execution context will also popped out. So now the call stack is empty, right? There is nothing to invoke here. Now what event loop will do is, so this is the event loop. So what this event loop will do is, it will check whether it has something in this micro task queue or the callback queue to be picked up and placed under the call stack to run. Now we are already at time t1, right? At time t1 we have already fired the name endpoint, and time t2 we have already fired the endpoint for description API. Now after 1 second, right? After 1 second, the description endpoint will return a response. So the promise will be resolved. So once the promise is resolved, this callback function, right, which is this, will be available here in the micro task queue. So we have this callback function to be executed once the promise got resolved for the description endpoint, right? And now the call stack is also empty. So what event loop will do is, it will just read it will see that there is a callback function to be picked up from microtask queue. It will pick it up, right, and just place it into a new execution context on the callback, on the call stack, and then execute it. And over here, what this will print is, it will print this message, description is, right, and this is what you saw on the console there, right. After this, after another 1 more second, right, now you will also get the response from the name endpoint, right. And so now this is gone, right, this has already moved to the call stack and been executed. So let's say that was for execution context 3, right, and this is also popped out after printing the console log. Now after this 1 second, right, we have also received the response from this /name endpoint, and the callback function as part of the promise resolution would be placed here in the microtask queue, and this would be for the name, right. Again, event loop will check whether the call stack is empty and it has something to be picked up from the microtask queue, and it sees yes, there is one new entry, so it will just pick this up and create a new execution context here, which will be EC4, and just run that callback function. And over here this will print this console log name, right, and now we will have the response as we just saw on the console tab of the DevTools. So this is how the execution is being done by JavaScript, and this could be problematic, right. There are ways to handle it, and we will cover those mechanisms in the upcoming videos, like callbacks, consuming promises using then clause, consuming promises using async await. So all these topics which we can use to handle the asynchronous behavior will be covered in the upcoming videos. So in the end, just one request: if you like the content and if this was helpful for you, please do consider to like it, share it with your network, and also leave a feedback for me. Let me know what else I should be covering, or what other topics I should cover as part of this series. We'll be looking forward for your support. Thank you.